Okay, in this lab, we're going to do a synthesis reaction of copper oxide, and we're going to do that from copper. So we'll begin with a crucible, which we'll get the mass of. So you're going to go ahead in the simulation and record the mass of the empty crucible. Then you're going to remove from the materials shelf. Here we've got it, the copper. This is a fine copper powder. And we're going to record the new mass of the crucible with the copper. You're going to record that in your notes. I'm going to go ahead and turn on the gas. Throttle that down just a bit. And we're going to go ahead and get some observations. I would describe it as a reddish tinted color. And I've got it over the nice flame. And I see a reaction starting to occur there. Pretty cool, pretty hot actually. So go ahead and make notes as to your observations. I'll show you some before and after shots of what's going on here, but it's essentially undergoing a chemical reaction, and copper is forming copper oxide. I'm gonna go ahead and give it a little stir up here. You can see some of the colors. As it oxidizes more thoroughly, definitely changes color. Okay, it looks like the reaction is done as the color is not changing. So I'm going to go ahead and remove the crucible. I'm going to turn off my flame. Hopefully I didn't melt the camera. And what we would do now, wait for it to cool a little bit. And capture the new mass of the crucible plus the contents, which is going to be copper oxide. And I'm going to demonstrate color difference, if you can see it. This in my hand is copper, and what we've got is oxidized copper in the crucible. So you could tell that the copper was much more of a reddish color, and it's definitely a gray black for the copper oxides. So you will have had the mass of the crucible plus copper. Then we went ahead and hit it with flame, and you'll get the mass of the crucible plus the copper oxide. From that, you can go ahead and work through the laboratory and derive that empirical formula. So okay, for this experiment, we're going to synthesize copper oxide from copper 2 sulfate pentahydrate. So essentially this is copper sulfate pentahydrate. It's a nice, very pretty blue salt. And in a simulation, you're going to take 25 grams of this what we're going to do is we're going to take a 250 ml beaker. We're going to obtain the mass of that and record it. Then we'll go ahead and add the copper sulfate pentahydrate to the beaker. You're going to go ahead and mass that. Now you'll have the mass of the beaker plus the copper sulfate pentahydrate. This is water. Now I'm going to make an aqueous solution of the copper sulfate. So I'm going to go ahead and add the prescribed amount of water to the copper sulfate. You can see it doesn't readily dissolve without a little bit of stirring, but it's very soluble, so it'll go in pretty easily. There's just a little bit more to go. So the next step would be to take 6 molar sodium hydroxide, which I have right here, and I dispensed it from the, oh, that's hydrochloric acid, sorry, just the opposite. Here's sodium hydroxide, 6 molar, that's pretty concentrated. And I'm going to go ahead and add the prescribed amount of that to this once it's all in solution. And I'm going to add the strong base to the copper sulfate. And check this out. I'm going to do it slowly. And the reason I'm going to do it slowly is that it's going to precipitate another compound. And what we should have here is copper hydroxide and sodium sulfate. The sodium sulfate will be soluble in the water, and the copper hydroxide is a insoluble precipitate, and that's what you can see there. Now in the simulation, they've got you just decanting this. This is actually a little bit of a challenge in real life. As you can see, we've got a great deal of precipitate. I'm going to go ahead and try to decant as in the simulation, and let's see how it really works out in real life. And it's very challenging. It is very challenging to really decant this. So what I'm going to do is I'm going to pause the video and I'm going to try and let that settle. But when we come back, the water is going to be separated from the copper hydroxide, and then we can proceed with the lab. So it's Mr. Davis back here again, and as you can see, it didn't really settle out. So there's a few options we've got. We could do a number of things to isolate the precipitate, which is the copper hydroxide. You could filter it. Decanting obviously doesn't work, but what I'm going to try, and I think will work probably best, is I'm going to centrifuge it. So that's just basically like a washing machine spinner, and it's going to use centrifugal force, and it's going to pull the solids down. So I'm going to go ahead and transfer it to a centrifuge jar. Make sure it's clean. what I'll do is give it a deionized water rinse. So when you run a centrifuge, you want to take another bottle. If you've just got one, you want to have the centrifuge balanced and have the load balanced on both sides of the rotor. I'll show the inside of the centrifuge. Looks like that. So I'm going to go ahead and fill this one here with some water just to balance things. Okay, so I've got the same amount in both of these containers. And I'm going to go ahead and load them into the centrifuge. There we are. And now I spin this baby up. I'm going to try it about 5,000 RPMs for about 5 minutes. And start this. So what that's doing is it's spinning up. You can see the RPMs go. So our 5-minute spin down is over and it's winding down. We're waiting for it to stop, and I'm going to unload and see if our centrifugation was successful. And it stopped. Let's see what we get. That's the water. And look at that. Now this is something I can decant. Isn't that nice? So now I can pour off the water layer, and then we can remove this solid precipitate. Now I can easily decant. And look at that. Isn't that beautiful? Check it out. The solid isn't coming out, and that's just what we want right there. Welcome back to the final portion of the synthesis of copper oxide from copper sulfate pentahydrate. In the last videos, we went ahead and we isolated the solid copper hydroxide, and this is what it looks like. It was an arduous task to remove from this bottle here. I did that by scraping it out, and then I used some water to rinse it all. One good question is, if I did not do that, would the numbers work out all right? In other words, something else existed in that aqueous layer before. And so that's something to think about as far as a source of error. However, I rinsed it thoroughly and then removed as much of the liquid as I could. So primarily what I have here is copper hydroxide. It's a little wet, but most of the aqueous portion that existed before is gone. So if there were any salts in there that were in the solution that I decanted away, they should not be present in this. So now the final step is to heat this over a flame, and it should react. As you can see, it's bluish now, a little bit of a dark blue, and I'm going to heat it over a flame, and we'll get a chemical reaction to finally yield our copper oxide. This crucible here, with a nice little handle, I've already recorded the mass, and in the simulation the goal was to do this in a test tube. In practice, the test tube isn't very practical, and I found it better to use this crucible. So in lieu of the test tube, we do have a crucible. So I'm going to go ahead and light the flame. Adjust it right. So this is going to go ahead and proceed as it is, and I'm going to not have the flame too high, but it's going to essentially completely convert this copper hydroxide into copper oxide. So as you can see, we've got our nice dry copper oxide, and we've got from before the mass of this crucible, and we've got the gross weight of the crucible plus the copper oxide. Take the difference, that's the mass of the copper oxide, and you can go ahead and work through the laboratory to get your empirical formula. But this is what the product looks like at the end. It looks like just like the stuff that you received at the end of part 1 or experiment 1, where you took copper over heat to obtain copper oxide. Here we did it in a multi-step synthesis fashion, where we went from copper sulfate pentahydrate via base to a copper hydroxide, filtered, decanted, or otherwise I centrifuged it, took away the mother liquor that's going to have some other salts in it. I've got the copper hydroxide isolated, we just heated that up, and now I've got copper oxide. And there you go. That concludes the second portion of the lab for empirical formula, and we'll look forward to seeing you guys during the lab sessions. Thank you. Bye-bye.